Okay, let's see how do we draw these graphs. So we will show this with an example here. We have fx is equal to minus x squared plus 2x plus 8. So in order to draw these graphs, we need our values, our vertex formula, and then we will need our roots of our quadratic equation and the value of y. And also we will need to find our constant value, which actually we know here. We will put this value also on our graph. So let's start with the our vertex formula. What was it? It was V, H, and K, which is equal to here H. It was minus B over 2A. So here minus B, it's minus 2 over 2A, it's minus 2, which is equal to 1. So after that, we will find the value of K. K is equal to FH, which is equal to F1. And from here, when I put 1 instead of x, it's minus 1, minus 1 plus 2 plus 8, which is equal to 9. So these are our vertex formula, vertex points, okay? It's 1 and 9. So after that, we know our constant term, it's 8, which is our y-intercept, okay? When you put 0 instead of as we said before, if you put 0 instead of x, we will get our y, and when we put 0 instead of y, we will get our x values, okay, x1 and x2. So here our y is equal to 8 when we put 0 instead of x, and when we put 0 instead of y, let's look what we have here. It's 0 is equal to minus x squared plus 2x plus 8. So we can write this as like x squared minus 2x minus 8, which is equal to 0. So from here x and minus 4 plus 2, it's minus 4x plus 2x, it's minus 2x. So x1 is equal to 4 and x2 is equal to minus 2. So let's put all these on our graph. So how do I do that? I draw these lines, and here let's start with our vertex formula, vertex point. Here I have 1 and 9, right? So here it's 1, and here we have, let's say, 9 somewhere here. So this is our vertex point. And then our x values, x-intercept, these are 4 and minus 2. So I put 4 here and minus 2, let's say somewhere here, okay? So these are our roots. And also we have our value of y, here it's 8, okay? So this parabola will pass through these points, and I will try to, it will be something like this. Sorry, I couldn't draw it very well, but it has to pass through these these roots and this value of y, okay? So it will be something like this. This is your vertex point. Actually, this also has to pass vertex point, but I couldn't. Something like this, okay? So this is your vertex point. As you can see, this point, since you have the negative value, a as a negative value, your vertex point is on the highest point, okay? It cannot be higher than this. So this is your vertex point, and your parabola should be like this. In this example, we have y is equal to minus x squared plus 2x plus 8, and these choices are given, and we will find the right one. We will find the right answer by doing the elimination method, okay? So let's start with our quadratic equation here. We have minus x squared, which means our value of a is negative, and that means that our parabola has to be something like this. It cannot be something like this, okay? That's why we eliminate the choice of D here, because it has an upward curve. So we cancel the choice D, And let's continue. Here, if we give if we write 0 instead of x, we will find our y-intercept, right? So actually it is equal to our constant value. So y has to be equal to 8. So when I look these choices, I see here we have 8. Also here we have 8 because our parabola, it has to pass through this point, okay, through our x points and through our y point. So here, since we have 6, we can eliminate the choice of B. So let's look at the other two. Here their x values, they are only the difference, the values of x's. So how can I do that? If you write 0 instead of y, you can find the value of x, but you don't have to do that. You just can put these values instead of x and you can check them. For example, if we put 4 instead of x, let's say here minus 16 plus 8 plus 8, here is plus 16 minus 16, it's equal to 0, so this is correct. So when you put minus 2, you put minus 3. For example, let's put 3 here. When we put 3, it is minus 9 plus 6 plus 8, right? So minus 9 plus 6, it's minus 3 plus 8, it is plus 5. It's not equal to 0. So it means that this is not the root of this quadratic equations, which means that this choice is also wrong. So B is the right answer. Okay, let's see when you have something like this. For example, there is no x, there is no constant value here, right? But it is still a quadratic equation. The only rule that you have to have a term with x squared. Okay, so here there is no term with x and no constant term. In these cases, you don't need to find vertex points. We just look at the values and then we put on the graph. Let's say this is y is equal to 3x squared. Okay, so when x is equal to 0, y is equal to 0. When x is equal to 1, y is equal to 3, right? It's 3 times 1, it's 3. When x is equal to 2, y is equal to 4 times 3, it's 12. So you write all these values. For example, when x is equal to minus 1, y is equal to, it's minus 1 is 3. When x is equal to minus 2, y is equal to 12. So you just write these values and then you just draw your graph as following these. When x is 0, y is 0. When x is equal to 1, y is equal to 3. Okay, when x is equal to 2, y is equal to 12. It's somewhere here. When x is equal to minus 1, y is equal to 3. And when x is equal to minus 2, y is equal to 12. So you just put these values on this graph, and then your parabola will be something like this. You will just do these points and then you will just make them together. It will be something like this. Okay, so this will be your parabola. You don't need to find your vertex point. This is actually much easier. You just find these values and then you will put them on your graph. Okay, let's see when you have an extra constant term here and you still don't have the term with x. So here we have plus c, right? It's actually same. We will apply the same thing. Let's try one example. Let's say y is equal to minus 2x squared plus 1. Okay, so let's do that. When x is equal to 0, y is equal to 1, right? And it's 1. When x is equal to 1, y is equal to, it's minus 2 plus 1 is minus 1. When x is equal to 2, y is equal to 2 squared 4 minus 8 plus 1, it's minus 7. When x is equal to minus 1, y is equal to minus 1 squared, it's 1, and here we will get minus 1. And when x is equal to minus 2, y is equal to 4 minus 8 minus 7. So same thing, you just draw your graph here, and when x is equal to 0, y is equal to 1. Okay, so when x is equal to 1, let's say here your y is equal to minus 1. Okay, here minus 1. When x is equal to 2, y is equal to minus 7, somewhere here. And when x is equal to minus 1, y is equal to minus 1. And when x is equal to minus 2, y is equal to minus 7. And then you put these like in your parabola, it has to go through your y point and these points, so it will be something like this. Okay, so it has to go through these points, okay, because I couldn't draw very well, so I will just do like this, but don't forget this parabola has to go through these points, okay. So from here, yeah, something like this, okay. So if you realize, actually there is a very important point here. If there is no term with x in your equation, okay, if you find this part, for example, when you find x values for x1, 0, 1 and 2, actually the other terms for the other values for x is equal to minus 1, minus 2, minus 3, they're also same, they have the same value. For example, when x is equal to 1, y is equal to minus 1. When x is equal to minus 1, y is equal to minus 1. Why? Because you don't have any term with x, right? So it does not change it, because here you have only x squared, which is it doesn't matter if it is negative or positive, it will be still it will become positive, right? So it will always be the same value. So if you find, for example, just for positive values of x for y, you can also apply the same thing for the negative values of x for your y values. Now let's see how to find the equation when we know the vertex formula. So what was the vertex formula? It is VHK, right? So if this is given to us, then we can find the equation. So let's see how do we do that. So here we have an example. In this example, on this parabola, we know that these points are the vertex points, right? These are the vertex formula. So here h is equal to 2 and k is equal to 11, right? These are our vertex points. So let's write them down. So these 2 and 11, these are our vertex points. And we can see that this parabola intersects y at 7, right? Which means when x is equal to 0, y is equal to 7. So this is the standard form of quadratic equation or parabola. Ax squared plus bx plus c. There is another form actually, which we called it as a vertex form, which is equal to y is equal to a times x minus h squared plus k. Okay, you can also write these like this. They are same thing actually. So here, if you know this value h and this value k, okay, all you need to do is to find the value of a, and after that you will be able to write the equation. So how can I do that? For example, you just take any point from any point on parabola, okay, and since it is on the parabola, it should give us the right value of a. So here we know that when x is equal to 0, y is equal to 7, right? If I put these points on this equation, I can easily find the value of a. So let's do that. So 7 is equal to a times 0, x is 0, minus h, it's 2, right? square plus k, it's 11. So from here, this is minus 2 square, it's 4, so it's 7 is equal to 4a plus 11, which from here 4a is equal to minus 4 and a is equal to minus 1. And after that you go just you take this value and just put that on its place, and that's why our equation is equal to minus x minus h is equal to 2, right? Square plus k, which is equal to 11. So this is our answer. You can also extend this expression here, and then you will get something like this, but you can also leave the answer like this. It's okay, because they are the same actually. So this is how you should deal with this kind of questions. Now let's see how to find the equation when the intercepts are known. So if you have two intercepts, x-intercepts actually, here x1 and x2, this is the formula you need to use, which is y is equal to a times x minus x1 times x minus x2. So you just go and put these values on their places, and after that you will do the same thing as we did before. To find a, you will do the same thing actually. And if you have, like for example here, when the equation has only one x-intercept where the parabola just touches the x axis, you will use this formula, which is y is equal to a times x minus x1 square. Actually they are the same, but in this formula, since the roots are the same, they are same, I mean x1, we just write them like this, like square. We don't need to write as here. So actually they are the same. So these are the formulas you need to use in order to find the equation. Let's look at this example. Here this graph is given and m is asked. So here how can we find m? As you can see, this parabola intersects x at the 2 points, right, which are x1 and 0 and 6 and 0. Okay, to find m, actually we need to find the equation, and after that we should find f1, which is equal to m. Why? Because when x is equal to 1, it's equal to m on y axis, on y axis. So how was the formula if I have two x-intercepts? It was, let me write it here, it is y is equal to a times x minus x1 times x minus x2, right? So y is equal to a x, what is x1? It's minus 1, and it will become plus 1 x minus 6. So from here after that, how we can find a? Again we will use our constant term here, which is when x is equal to 0, y is equal to 2, right? So I can use this because these points, they are on our parabola, which means if I put this value here, it has to give us the right value of a. So let's do that. 2 is equal to a, x, it's 0, so it's 1 times minus 6, right? So from here, a is equal to minus 1 over 3. So after this, I will be able to write my equation, which is equal to fx is equal to y, which is equal to, it's a minus 1 over 3 times x plus 1 and x minus 6. Okay, this is our equation. So in order to find m, I should put 1 instead of x. So let's do that. f1 is equal to minus 1 over 3 times 1 plus 1, it's 2 times 1 minus 6, it's minus 5, which is equal to 10 over 3. Okay, let's see how you find the equation when you know at least 3 points on the parabola. So when these 3 points are given, and if these 3 points are on the parabola, it means they should provide the equation correctly. You will write these 3 points on the equation ax squared plus bx plus c, and you will get 3 different equations. There are 3 unknowns a, b, c, and you have 3 equations also, which means you can solve these equations. It takes some time for sure, but let's look at this example and you will see actually it's a very easy process. So let's see. Find the equation that intersects at the points 0, 6, minus 3, 9 and 4, 30. So let's say our equation is y is equal to ax squared plus bx plus c. Okay, so let's start with this point. So here, when x is equal to 0, y is equal to 6, which means y is 6 when x is equal to 0. So when x is equal to 0, actually this will cancel, this will be 0, so which means c is equal to 6, right? So we simply found the value of c. So after that we will put these values on this equation. Let's do that. When x is equal to minus 3, y is equal to 9, right? So let's write it down here. So we have 9 is equal to ax squared, so it is 9a, because x is equal to minus 3, x squared, it will be 9, so it's 9a minus 3b, right? Because x is equal to minus 3 plus c, which is equal to 6. Okay, so let's leave this equation here and then let's look at this one. When x is equal to 4, y is equal to 30, right? So let's do the same thing. So y is equal to 30 when x is equal to 4. So let's put here a as 4. It's 16a plus 4b plus c is equal to 6 plus 6. So as you can see, we found another equations here. So we will try to destroy one of these unknowns. So if I multiply here by 4, okay, and then this equation by minus 3, these b values, they will actually cancel each other out. Let's see. So here it's so this is 4 times 9. It's 4 times 9. It's actually we should write them correctly, because here we have 9 and here we have 6, right? So if I put this 6 here, it will become 3, which is equal to 9a minus 3b, and here we have 30 and we have 6 here. When I put the 6 here, it will become 24, which is equal to 16a plus 4b. Okay, now we can continue. Here we have, in this equation, when I multiply by 4, I will get 12 is equal to 36a minus 12b. So I get minus 12b, and when I multiply this one by minus 3, I will get plus 12b. So let's do that. When I multiply minus 3 by 24, it will become 72, which is equal to, this will become 48a. Sorry, this is not minus, this is plus, of course. 48a, and then here plus 12b. Okay, so when I sum them up together, this will become also plus. Sorry, so these will cancel out each other, and from here 84 is equal to 84a, and from here a is equal to 1. And after that we will put this value in one of these equations, and let's say here it's 3 is equal to 9 minus 3b. So when I put here 3b is equal to 6, b is equal to 2. So from here we found actually our equation, which is equal to y ax squared, so a is 1, x squared, so plus bx, b is equal to 2 plus 2x, and plus c, which is equal to 6. So as you can see, this is our equation. Now let's see how do we draw the graphs of inequalities. So here we have y is greater than or equal to x squared minus x minus 6. So first think this as a normal parabola, okay, like this. Y is equal to x squared minus x minus 6. Okay, we will find the points of this parabola or quadratic equation, and then we will draw the graph of this. So let's do that. How do we do that? First, you find x-intercepts and y-intercepts by giving values 0 to each other. First, let's give 0 to y to find x-intercepts. So 0 is equal to x squared minus x minus 6. So I can actually factor this. This is x, and this one minus 3 plus 2x minus, yes, this provides. So from here we get x1 is equal to 3, x2 is equal to minus 2, right? And then let's give 0 to x, so it will be our y-intercept, which is equal to minus 6, right? When you put 0 instead of x, you will get minus 6. Okay, so after finding these points, let's put them on the graph. So here it's minus 2, right? It's 3 and minus 6. It's somewhere here. So since our value of a is positive, it will be something like this. Okay, so you should draw the curve of the parabola as a normal curve line like this. Okay, why? Because there is also equality here. If there is no equality, if this is something like, let's say y is greater than x squared plus 2x minus 3, okay, as you can see there is no equality, just it says y is greater than this equation, and then you have to draw this parabola as dotted curve line like this. Now we will solve actually another example, and actually you will understand this concept better. Now let's see how we draw the graphs of inequalities. So here we have y is greater than or equal to x squared minus x minus 6. So first think this as a normal parabola, which means think this as like y is equal to x squared minus x minus 6. Okay, and then you should find x-intercepts and y-intercept by giving value 0 to each other. Let's do that. First let's give 0 to y, and from here we will find our x-intercepts. So 0 is equal to x squared minus x minus 6. From here it's x and minus 3 and plus 2. It's minus 3x plus 2x, yes. And now from here we will get our x1 is equal to 3 and our x2, which is equal to minus 2. Okay, so these are our x-intercepts. And then when you give 0 to when you put 0 instead of x here, you will find your y-intercept, which is equal to minus 6, right? Because when you put 0 instead of x here, it will be 0, and then we will find minus 6. Okay, so after finding these points, I will just go and put these points on the graph. Okay, so here we have -2, here we have 3, and we have -6. Okay, somewhere here. So since your a is greater than 0, it will be something like this. Okay, your parabola. And you should draw the curve of this parabola as normal curve line, since there is also equality here. If there is no equality, if your inequality is something like this, for example, y is greater than x squared plus 2x minus 3, okay, if it's something like this, you see there is no equality here, it's just say y is greater than. So in these cases you should draw your curve like this dotted curve line, but in our case we also have equality here. That's why you should draw your curve as normal curve line like this. Okay, and then it say y is equal to, okay, or greater than this equation, which means this part, because greater than, it includes the upper part, right? Okay, so this is actually your the graph of your inequality. Whatever point you take from here, this equation must provide the correct points. So this is how you draw your graph. Here we have y is greater than or equal to x squared minus 6x, and y is less than minus 2x squared plus 8. Draw the graph of the solutions. So let's start with the first one. It's y is y is greater than or equal to x squared minus 6x. So we will think this as a normal quadratic equation. When we think it like that, y is equal to x squared minus 6x. So here when x is equal to 0, y is equal to 0, right? So when y is equal to 0, then this is x squared minus 6x. So 0 is equal to x minus 6. So x is 0 and x is equal to 6, right? So these are our points. And then let's put them on the graph here. First we will find this one, and then we will find the second one, and then we will combine them together. Okay, so here we have x, when x is equal to 0, y is equal to 0. Here when y is equal to y is equal to 0, x is equal to 0, and x is equal to 6. Okay, since there is also equality here. Okay, how you're gonna draw your curve as a normal curve line, right? So it will be something like this. It will pass through this point, okay, and then from here like this. Okay, so this will be your first equation, first inequality, sorry. So after that we will do the second one. This is the same thing. So we will think this as a normal quadratic equation, which is y is equal to minus 2x squared plus 8. Okay, so when x is equal to 0, y is equal to 8. Okay, when y is equal to 0, it's minus 2x squared plus 8. So when I put this here, it's 2x squared equal to 8 is equal to 8, and from here so this will come 4. So x squared is equal to 4. So x1 is equal to 2, x2 is equal to minus 2. Okay, so let's also put this on this line. So let me write it with another color. So here it's 2 and minus 2. So 2 is somewhere here and minus 2 is somewhere here, right? And your y point, y-intercept is 8. It's here. So here we don't have any equality, right? It says y is less than this equation, this parabola, this quadratic equation, which means it should be with dotted curve line like this. Let me draw. It will be something like this. Okay. Okay, so if there's equality here, then we would draw this as a normal curve line. But since there is no equality, we should draw this like this. And after that, you just need to find the common part of these two graphs, which is here, right? This is your first graph. This is your first inequality, and this is your second inequality. And the common part of these two is here. So this is the graph of these two inequalities. In this example, we have y is less than x over 2 plus 2, y is greater than or equal to x squared. So here we have linear equation, but we will do the same thing. You just think this as a normal equation, and then when x is equal to 0, y is equal to 2. When y is equal to 0, x is equal to, if y is equal to 0, then this will be minus 2. Minus 2 times 2, x will be equal to minus 4. Okay, so this will be your point for this linear inequality. And then here we have y is greater than or equal to x squared. So you know how to draw when x is equal to 0, y is equal to 0. When x is equal to 1, y is equal to 1, and then it goes like this. When x is equal to 2, y is equal to 4, right? So it is something like this. So let's draw these two together. Here we have our lines, and this y is since we have equality also here, it will be with normal curve line, okay, which is something like this. Okay, so this is y is equal to x squared. This is equal to x squared line. But this is when y is greater than or equal to x squared. It is something like this. Okay, the upper part of this, because it say y is greater than or equal to. So this is your first one actually. So here is y is greater than or equal to x squared. So for the first one, it should be normal straight line. Let me draw this with this one. So when x is equal to 0, y is equal to 2. So it's something when x is equal to 0, y is equal to 2. And when y is equal to 0, x is equal to minus 4, right? So this line will pass through like this. Okay, so this is your first linear inequality. Actually this is y is equal to x over 2 plus 2, but the common part of these two is equal to here. Let me draw with this one here. So the answer to this example is this part. So this is the graph you need to draw. In this example, we have y is less than x over 2 plus 2, and y is greater than or equal to x squared. So here we will do the same thing. This is we will think this as a linear equation. Here we will think this like y is equal to x over 2 plus 2. So when x is equal to 0, y is equal to 2. When y is equal to 0, so x will be minus 2 times 2 minus 4. Okay, so let's draw this one. So this is not quadratic, as you can see. This is linear, so it will be just a straight line. So when x is equal to 0, y is equal to 2. Okay, so when y is equal to 0, x is equal to minus 4. Okay, so this will be the line. And after that, this one, y is equal to or greater than x squared. So when x is equal to 0, y is equal to 0. When x is equal to 1, y is equal to 1. When x is equal to 2, y is equal to 4. And the same goes for -1 and -2, right? Because we did this before, and the parabola looks like this. But as you can see here, we also have an equality. That's why it should be normal curve line, okay? It will not be dotted curve line. So let me draw this with another one. So it will be something like this. Okay, so this is when y is equal to x squared, and this is your graph. So it says y is greater than or equal to. That's why, let me just make this like this, and this one like this. So equal to or greater than, that's why it will be the upper part, okay? And for this linear inequality, it says y is less than this one. That's why this part we will draw, okay? So this part. So where's the common part of these two inequalities? It's here, right? So this part of this graph is your answer to this example.